Hello, and welcome to a little video about vertical dilations of functions. All right, so the previous lesson we translated our functions. That's when we took our functions and we moved them up, we moved them down. So we moved them, nothing changed about them other than their position on the graph. Now we're going to dilate them. Let's think about that word, dilating. You may have heard about it when you were learning about, let's say, your eyes. I think that's probably the most common example. When you're moving from dark spaces to light spaces, your pupils will dilate, so they'll get larger and smaller. And that's essentially what we're going to be doing to this 2D graph. We're going to be making it kind of larger and smaller, and we're going to have to see what that looks like on these lines. So let's keep that in mind. I think another time that I can think of where we dilate our pupils is when you go to the eye doctor and maybe you're getting tested, your vision's getting tested, and they will dilate your pupils to look inside, and they get bigger. It's kind of a weird experience if you've ever gone through it. Let's get started. Let's see what that looks like on these lines. All right, so here is our parent function. Let's suppose the output of the values are changed by 4. Now, what this means, when you see factor, we're multiplying, multiply by 4. All right, so let's see what happens when we multiply by a positive whole number. Okay. So our x's stay the same. We've noticed that about translations too. So our y's are also the ones that are going to change when we are doing the dilations. Let's do it. -2 times 4 is -8. -1 times 4 is -4. 0 times 4 is 0. 1 times 4 is 4. 2 times 4 is 8. Let's graph those points. All right, give me a second. I'm going to make my pen a little thicker so I can just do little points. All right, -2, -8. So I go to x is -2, then down to -8. -1, -4, 0, 0. 1, +4. 2, +8. Okay. We're going to pretend that I'm drawing a straight line because I'm not that great at it. But when you're doing it on paper, I hope you are using a straight edge, like maybe your ID. All right, so there's our line. It looks steeper. It looks like a way more fun slide at a water park. I don't know why I'm thinking about a water park while it's snowing outside. Maybe I'm just dreaming of summer. But I love winter. Anyways, let's see how this changed our equation. So our original function was f of x equals x. That's the basic parent function. Let's see what this one's going to look like. All right, this one is called a of x, and it's mx plus b. M is our slope. Let's check it out. I'm going to use these 2 bottom points. This is left, that's right. I'm going up 1, 2, 3, 4. To the right 1. So our slope is 4 over 1, which is 4. B is our y-intercept. Let's check out what our y-intercept is. And it looks like it's right here at 0, 0. So 0. You can also tell by looking at our table, there's our y-intercept. Okay, so a of x equals 4x plus 0. Or we can simplify it by just writing 4x. We don't need to write plus 0. All right, I think in the last lesson I mentioned the rule of the invisible 1. If we're multiplying by 1, it's kind of silly. We don't need to write the 1. But in addition and subtraction, it's writing plus or minus 0. That's kind of silly. We're adding or subtracting nothing. So we don't really need to write nothing. Okay, so what changed between a of x and f of x? Check it out. The slope changed. It got larger. Let's check out what happens when we multiply by a negative number. Same idea, same f of x. Now we're going to draw a c of x. All right. Everything is going to get multiplied by -4 this time. -2 times -4 is +8. -1 times -4, +4. 0 times -4 is 0. 1 times -4 is -4. 2 times negative 4 is negative 8. This kind of looks like an upside down table of the one we just did. Let's see what that looks like on our graph. Okay, negative 2, positive 8 is all the way up here. Negative 1, positive 4, 0, 0. 1, negative 4, 2, negative 8. So it still looks steep, but it looks like it changed direction. Instead of going up, it's going down. It's decreasing instead of increasing. It's crazy. Pretend my line is straight. Oh, I just realized how ugly that looks. I'm going to try one more time, okay? I'm going to zoom in. Wow, I missed that completely. Thanks for bearing with me. Nope. Okay, you know what? That is as close as we're getting, and I'm just going to live with it. All right, let's identify the slope and y-intercept and write the equation. All right, so this one is called c of x. M is our slope. Let's find it. I'm going to use these 2 points down here. This is the point on the left. This is the point on the right. It looks like I'm going down 1, 2, 3, 4 to the right 1. So our slope is negative 4 over 1. Negative 4, thank you, over 1, which we can rewrite as just negative 4. B is our y-intercept. Let's check it out. Looks like it's happening at 0, 0, and you can also tell by the table. So my y-intercept is 0, which means our function is negative 4x plus 0, which we can also rewrite as negative 4x. Once again, you should notice that it's our slope that changed, okay? So, that's it. Our vertical dilations can make something steeper. It can make it flatter if we multiply by fractions, and it will also change it. It will reflect it. It'll make it go the other way when we multiply by a negative. And that's something to keep in mind. When we multiplied by the positive, we kept the same direction. When we multiplied by a negative, it flipped. It was a reflection. So it changed direction completely. I hope you found this helpful. If you have any questions, please make sure to ask me or your teachers if you're watching it from someone else's class. Have a wonderful, wonderful rest of your day. I'll make more videos later. Bye!